Okay, so what did we learn previously? Last time, what did we do? We talked about taking a binomial distribution and call it a normal distribution, right? Okay, we were able to do that, and we had three things we didn't look at. There were conditions that had to be met. They were...
Binary.
Oh, well, no, that's the binomial. To make the transition from binomial to normal, we said that first of all, it had to be a random sample, and then it had to, we could not oversample. We could only sample up to 10% of the population, and then we had the large counts. We said that this and this both have to be set aside. We said that these are, this has to be, this had to happen. Okay, so those were the three conditions that had to be met, and if they were met, we could go ahead and redo those. And we said that on the normal distribution, we would say that the mu would be equal to this, and our standard deviation was going to be this. Okay, so this is where we stopped. I think this is as far as we got. We did example number 1, and we are going to today continue on with that same example, and we're going to do example number 2. In example number 1, so let's go back. We talked about Mendel's P's, right? We talked about Mendel's P's, and in that we had, let's go do example number 1. Go back to example number 1. Example number 1 says we were doing 580 of the offsprings, and 145 of them would be yellow. We thought 145 would be yellow, and that's where we were at. Okay? We checked all the conditions, and then we said since 0.25% of them were going to be, this is our n, so this is going to be equal to this. And if we did that, it was 145, this was 145, and we said that this guy was going to be 580. We're going to multiply this by to get our standard deviation. 0.25 times 1 minus 0.25, correct? This is the Q, NPQ. And if we did that, we ended up with 10 something, if I remember correctly. 10.42, 10.42. So this is as far as we got. Okay? And then we did something based on that, and today we're going to do something else based on that. Said using the same information for example number 1, so we're back to example number 2, we are on page 287. Find the probability of exactly 152 P's. 152 P's. So we are here, and we have a binomial that we are actually going to be just call a normal, and we are at 145, and I want to know 152 exactly. Okay. Now remember, we had this thing called continuity correction. Okay, when we were doing, said we wanted to do 152 and greater. We said instead of 152, we did what? We did 151.5, right? To include that, okay? So it would stand to reason that if you wanted the 152 exactly, you would go from 151 and a half to 152 and a half, right? Right in between, because that's where this would reside in, right? Right between those two. So you would just do a norm CDF, and you lower would be 151.5, 152.5, with a mean of 145 and a standard deviation of 10.42, right? And that, you should be able to do that. And just, if you do that, what do we get? Can somebody do that for me, please?
0.0305.
0.303. .0305. Okay. Somebody do this for me. Norm PDF 152, 150 this 10.42. 0.03.5. PDF is the, okay, unlike the CDF was what? Cumulative, right? So from a certain point to a certain point, right? This is the actual probability distribution function. So it is that point, that one single point. Okay, and that's that one single point of 152. Okay, we calculate that one single point of 152 with a mu of this and a standard deviation of that. Okay, we have not used PDF before. Okay, I'm kind of introducing this at this point. Okay, you will have very little reason to use it, but just in the back of your mind, remember that you can use it. Okay, this is the actual probability distribution function at that point, whereas cumulative would have been from a certain point all the way up to a certain point. Okay, that's the difference between the PDF and the CDF there. And we can also, yeah, you can do this on the table, but hey, when you got technology, there's no reason to do that, so we'll just continue to use the norm CDF. Okay. Okay, so that's really all about what I'm going to do today. So let's kind of look back at 6.6 as a whole, which actually what we did today, right? We did, so we have, so go to page 285. So 285, the top page of 280, top half of 285 is what really kind of, in a nutshell, tells you what you need to know for 6.6. Okay? If you understand all this, you're good to go. All right? Continuity correction is always going to be your boogaboo. You're going to forget about it. You're going to, instead of using 151.5, you'll use 152.5 or something like that. So be careful. Okay? Because you want to make sure that you include that. So if I said, they give you the same question, and I said 140, and I said at least greater than 140, what would your lower limit be? 140. Huh? It'd be 139.5, right? Because you want to include this, and at least would be, that means it would be on this side, correct? Okay. If I said 140 or less, you would use 141.5. 140.5, right? Okay. So you have to be very particular in trying to figure out, because you want this line included in whatever you're doing, right? Well, depending on it, right? So you have to make sure that you get that correct. Okay. Because, yeah, just doing this is stuff you should be very comfortable with. The only new thing that we're introducing here is that continuity correction factor. Okay? Okay, we're good. Your homework for today is going to be 11 through 15.